Gonna have a long intro for him, but
Yeah.
All right.
Okay, we good to go?
Yep.
All right, well, welcome everyone. Thank you for coming today to the FDR presentation for the Breath Strummer design project. For the few of you who might not be familiar with the project, let me just catch up really quick. Our project is to design a device that can attach to a standard acoustic guitar that will enable someone who has lost the use of one of their arms to play the guitar. Our customer, Ruud van der Vel, is the founder of My Breath, My Music, a foundation out in the Netherlands who focuses on creating instruments for those who may have some disability and still want to play the instrument. So he asked us to create this device for him and his foundation. So I'm going to turn the time over to Randy, and he's going to talk a little bit about the requirements for our project and kind of walk you through what we've designed.
Thanks, Stephen. So our requirements, you can see, is that it needs to be able to strum all 6 strings, just the top 5 or just the top 4, to be able to account for different chords that are being played. There are, of course, many other different string combinations when playing chords, but this will cover all the basic open chords. It needs to be able to vary the strum intensity or the volume. So it needs to be able to strum quiet and strum loud, and then it needs to be user definable. It needs to be able to vary the strum speed, so 750 milliseconds, so a slow strum or a fast strum. And the device needs to mount to the guitar without weighing more than 2.5 kilos, just so it's not cumbersome or in the way or makes the guitar uncomfortable to use. Our goals are that the device should be as open source as possible, so use as many off-the-shelf parts as we can, not a ton of custom stuff, to keep it accessible and cheap. The point of this, Ruud would like to see this go online. We're going to make some documentation and put it on Instructables at some point, because he wants this to be open source, free for everybody to use, and let the power of the internet iterate to better and better versions. The other goal we had was to be able to individually play strings rather than just chords to even, further widen the playability of the device. So there's 3 sub-assemblies I have here. So this is the mouthpiece. This mounts into a microphone stand like this, and then either person sitting or standing. They'll blow into this tube here. Activates a pressure sensor. You can tell the difference between an inhale and an exhale. So if you blow in, it will increase the pressure, and that will activate a downstroke. Conversely, if you do an inhale and breathe in, it'll create a vacuum, and that will activate an upstroke. To change the volume, or the volume that you're playing, you blow or suck harder or softer. So the harder you blow, the louder it will play. It achieves this by activating these 2 on the side here. So the harder you blow, these will turn down, and the string and the picks will further engage deeper into the strings. So getting a bigger bite, creating more volume. The
Pictures up there if you want to point it out there too.
Yeah. Okay. Yep. Then to change the string selection, standard in the middle is 5, and then if you go down, you play the top 4 strings, and then if you go up, you'll play all 6 strings. To change the strumming speed, as you move left, it gets slower and slower, and then as you move right, it becomes pretty much instant. It just engages all the strings at the same time. There is a delay between each one, but it's pretty imperceptible. And then we actually did implement the single string playability note mode, I think is what we officially coined it. So if you go all the way slow or all the way left, then as you actuate up and down, down is your low E string and up is your high E string. And then evenly split 6 ways between that range of motion is how you select the string. Then the second subassembly is the controller. Can't really see it, but it's back behind this cover. It's the brains of the whole device. We went with the Adafruit feather basic. It's pretty small. It's like 2 quarters next to each other. It's pretty small. Has a servo shield or wing, as they call them, the attachment. It's a stackable board. So it natively handles the servos. Has built-in libraries for handling servos, so it made the code implementation a lot easier. The third subassembly is the strummer itself, so this whole thing. So how it works, as I mentioned, as you blow, it will activate these servos in order or in the one you choose, moving back and forth, and we'll strum the device. There's a battery here on the guitar that powers it. So this mounts, and we'll put this all together and do a little demonstration later. But, this mounts to the guitar, and these two will plug in. So it powers the controller, and then it separately powers the servos. So if you try to power the servos off the controller board, they'll rob it of all its power, and it'll just reset itself. And then the interface between the mouthpiece and the controller is just a standard Ethernet cable. We tried with Cat 5 and Cat 6, and it has to be Cat 6. Cat 5 only worked at about a length of 1 foot, and after that, it really it mixed up the signals a lot. The thing just went haywire. But with Cat 6, we've tried it all the way up to I think 6 feet, and it works just fine. So interfaces those. So those are different sub-assemblies. Like I said, we'll put it together in a minute, and we'll show you what it all looks like. Do a real demo. And turn the time over to Brett to talk about what we've changed.
So the one major change we've had since our critical design, it involves the mouthpiece. We've simplified the design so that how we had originally had it was one rigid plastic housing part. So this housing and the microphone interface was all one rigid part. And then the tube was not rigidly mounted to the housing. So the user would control position still very similarly, but the tube would be what could move relative to the housing. For a couple of reasons, we thought that was a likely point of failure for the design, potentially having the tube interface that way. And then also we felt like it could be more open source with simpler plastic parts. The one rigid plastic part was a little more complicated. This made the entire design a lot more streamlined, smaller plastic parts, less printing. And so we felt like it helped us achieve our goal of making the product more open source. So now, instead of the plastic being one rigid part, they're connected by a two-dimensional joystick potentiometer. So you still get the exact same motion that we had originally planned on, but with the two plastics being able to move relative to each other. Here's again a picture of the two motions that we get, and as I said, instead of getting that with the tube as originally planned, where we felt like we'd have a lot of connection issues, now the tube's able to be rigid, and we get all the motion with just the two plastic parts. As Randy pointed out, one of our requirements was to be able to vary the volume. Rude wants this to feel like a natural sound when the guitar is played, and so there's songs where you need to vary the volume, and that's one of the requirements. And so originally specified was the requirement of 65 to 80 decibels. We'll show you what we're getting with this quick video. So in this video, the decibel meter was placed at about 1 meter from the guitar. On our quietest strum, we were getting about 70 decibels. And then on our loudest strum, we were getting 78.5. We were close to 79. We had nearly a 9-point range. So we're not quite reaching the 65 to 80 decibel range that we had originally specified. Part of the reason we can't go quieter is because when a human plays the guitar, they will not strum with the pick perpendicular to the strings. A lot of times they'll lightly drag the pick across the strings. With our current design, that's not possible. Our picks are always perpendicular to the strings when they strum. There's not a way for them to be dragged across. So we don't feel like we're capable of reaching the bottom decibel of 65 in that range. We do feel like 70 is about as quiet as we can get. However, we do think that a range of 9 decibels is adequate because the way that the decibel scale goes, we're getting close to 8 times as loud on our loudest strum versus our quietest, and it's very noticeable to the human ear. You do get distinct quiet strums and loud strums. So we do feel good about it, although we're not reaching that 15 decibel range that we would have liked to early on. Again, there's probably, and we'll go into this a little bit, some ways you can make it louder, but with the current design, we don't think that you could get quieter. Also, as Randy pointed out, one of the goals was to individually be able to pluck strings. Here's a little demonstration of that capability. So you can see it is achieving both. It's able to pluck all 6 strings individually, as well as the various combination of chords that we need to. So we are achieving that. We do feel like it's a little awkward the way we're switching to that, as Randy pointed out, when the user goes all the way to the left on the speed scale, it switches to then single pick mode, note mode. We do feel like this is a little awkward for the user, and there are some potentially better ways to do that, which Steven's going to talk a little bit about later. So kind of as a summary of our requirements and goals, the requirement of being able to strum either 4, 5, or 6 strings we're meeting. You can see that from the video, and we're able to do that. To vary the volume, like I said, we had originally had a target range of 65 to 80 decibels. Unfortunately, we're not getting that entire range. We're 70 to 78 and even close to 79 at some points. As I said, with the current design, it can't get down quieter than our low end, but it is a very noticeable range, and we feel good about it. The strum speed, we had a target value of a 100 millisecond strum to a 750 millisecond sweep. This wasn't demonstrated, but that's coded into the program that runs the entire thing. So that's just a few lines of code, and we're doing that. We've also, I believe, done some measurements. They've been pretty rough, but we are achieving this varied strum speed.
It's hard to measure stuff.
Exactly, yeah, it's been pretty rough measurements with that, but it is hard coded into the program, just telling the servos when to go. The weight restriction, we had set a goal of 2.5 kilograms. We've got a mass of 0.8 kilograms. That's on the guitar. The mouthpiece is an additional 0.1 kilogram, but we didn't take that into account because that's mounted to the microphone stand and not part of the guitar. And then our goals, one of the goals was to make this design as open source as possible. We have hit what we believe to be a low cost, which again, Steven's going to address some of those things. And we've documented the entire thing really well. The only reason that we don't consider this completely achieved yet is because the documentation hasn't been uploaded to instructables.com. Once we feel like that has been done, we would be satisfied in saying that we've achieved an open source design. And then the other goal was to play individual strings. As you can see from the video, we are achieving that fundamentally. It's just that we feel like it could be done a little more intuitively. So with that, I'm going to give the time to Steven to kind of go over the budget of the project.
Thank you, Rhett. So I'm going to address budget really quick, and then I'm going to talk about some issues we've run into and some potential fixes for that in the future. So we were allotted $2,500 as a budget for this project. We spent about $1,300 of it for parts and manufacturing and things like that. Here's a quick breakdown of where we spent the money, and I'll show you a bill of materials in a second that's a little bit more detailed on what the actual strummer will cost. This will not be the cost to an individual customer. So we were under budget by about $1,200. The one thing that's not represented in this graph is the cost of printing the components, because that was done through the shop here on campus, so we were never billed for any of those and don't have a way to track what those cost. However, we did get an estimate that I'll show you in this slide here. So this is the total bill of materials for the breath strummer, along with the price for each individual component that's required. So you can see we've broken it down into the 3 assemblies: the strummer, the mouthpiece, and the microcontroller. This D shaft here is the aluminum shafts that hold it up. That had to be manufactured, so I put that in its own category, even though it's part of the strummer assembly. So in total, we estimate that the cost of just materials to assemble this particular model would be about $470. The price estimates for the 3D printed parts are from the EED lab on campus. They ran the numbers for us and gave us those. So this is, again, an estimate. We've looked through to see what ways a person could lower this cost if they wanted to. We bought a lot of our fasteners from McMaster, and if anyone's used McMaster, you know that you have to buy everything in bulk, so you get 100 of everything. And that's just not necessary. We need at most 10 of any one particular fastener. So if you were to purchase them from a different vendor, it's likely that you could save up to $80 is what we've estimated by not purchasing them bulk through McMaster. So that alone would lower the cost to about $400. Again, some of these things might be sitting around an individual's house, which was the hope when we were designing it. They might have things like an Ethernet cable, maybe they even have Ethernet ports, possibly servos or pressure transducers or a microcontroller sitting around already. So again, depending on the individual, this could be less, but worst case scenario, they had to purchase everything new, might have to buy new tools and deal with shipping costs. There is a potential that it could cost as much as $600 for an individual to make themselves. So now I just want to talk a little bit about what we learned personally from the project, and then some recommendations we have for anyone who wants to continue this project from where we brought it. One of the big things that we learned was the importance of taking really good measurements early on and using that to create effective requirements. One of the issues I'll address in a minute is the distance traveled by the strings when you finger a chord. This is something we just didn't consider early on, a measurement we didn't even think would be necessary. But as we've learned later, that having that little measurement could have greatly affected how we may have addressed some of the design decisions, but it wasn't something that we considered early on. So again, just making sure whatever project you're working on that you identify critical measurements or requirements like that could alter the design, the course of the design. We had hoped to iterate a little bit more on the breath strummer than we had the opportunity to. At least for a project like this, we felt like that's where it's going to get most of its long-term value and polish from, is various iterations. So we feel like making sure that we stick to a more strict deadline schedule for us personally definitely would have helped us a little bit. We were a little bit slow on some of the early requirements, and paid for a little later on in the amount of time we had to work on it. And then lastly, one thing that we learned is that it helps to have a budget that lasts the extent of the project. We had to jump through a few extra hoops during the second semester because our budget didn't exist second semester. And that slowed down some of our manufacturing time, which again hindered the ability to do some of the iterations we had initially hoped that we'd be able to do. And then lastly, I just want to address some of the things we recommend for anyone who wants to make this at home or iterate upon it. Randy is going to show you in a minute how calibration mode works. So when you install the breath strummer on the guitar, you do need to adjust the pick positions so that they engage the strings properly. We call this calibration mode, making sure everything's lined up. This has to be done every single time that the device is powered up, because the Adafruit Feather does not have any memory. So it cannot remember the position that you set it to. Obviously, that's super inconvenient and not something you'd want out of a finished product. So we recommend that the Adafruit Feather be replaced with the 32U4 Ada Logger, which you can insert a micro SD card into and then save the last position that you calibrated it to. That way you shouldn't have to recalibrate it every time you go to play it. Secondly, I mentioned that the action of the guitar action is the distance that the strings sit off the face of the guitar. That varies based on guitar, and it's something that many guitarists will alter to improve the playability of the guitar. We found that if you install the breath strummer on a guitar that has high action, it struggles to play because as you press the chords down, you will move the strings far enough away from the breath strummer that the picks do not always engage the strings. The simplest solution for this is to lower the action on the guitar, which is a very common practice in the guitar community. Many people do that just to make it easier to play the guitar. So by lowering the action of the guitar, the distance traveled by each string is far less, and the breath strummer has very little issue when you can minimize that distance traveled. Similarly, you can also use lighter gauge strings. The strings we have on this guitar right here are regular traditional medium gauge strings, and it plays them just fine. However, lighter gauge strings, of course, the servos are just going to have a slightly easier time strumming, and you might get a better sound out of it because you won't ever have the concern if you have inserted the picks too deep of them getting stalled on any of the strings. Randy will address this shortly too, but sometimes to make sure that the pick engages the string at the correct depth, you have to manually pull the pick in and out of the pick holder. We would recommend that each pick holder be designed specifically for the string it's associated with. So that way you insert it fully in, and then the depth that it goes in corresponds to the string that it's supposed to, because the picks are lined up linearly, but due to different string sizes and the way that it's laid on the guitar, the strings lay in a slightly slanted plane. So you're dealing with a linear plane against a slanted plane. And by adjusting the depth that the picks can actually go into the pick holders, you can compensate for that difference, that angle difference. And then Rhett mentioned that right now, in order to switch to note mode, you have to move the input device all the way to the left. This isn't very intuitive, and it's a little awkward, especially if you wanted to change the speed at which you're playing individual notes. The original plan was to implement some sort of toggle switch, either a foot switch or a button on the guitar that the user could press. We ran out of time to implement that ourselves, so we recommend that that be implemented very early on because it will be much more intuitive to switch between modes, and you will still get full control over the volume as you play the device. Similarly, calibration mode has to be done. Will you point out the wires there? Those wires there, you have to manually switch the leads on the wire to switch between calibration mode and play mode. Again, obviously not a very professional finish, and so we recommend that a toggle switch be installed there as well that can be mounted to the strummer frame itself to switch between the two modes. And then finally, some people have mentioned that the servos are a little bit distracting when playing the guitar. We believe that there are options to dampen it by encasing the servos in some sort of housing, and you could put some padding in there, some sound padding in there to muffle the sound. Or there's also similar size servos that are plastic gear instead of metal gear, which should be quieter as well. So anyone who wishes to dampen the servo noise a little bit can investigate either of those two avenues. So I'm going to turn the time back over to Randy, and he's going to do a quick demo for you, and then afterwards we will address any questions you might have.
If you have questions about setting up,
Yeah, if you've got anything while he's setting up, happy to answer. Oh, and I don't know if we mentioned, so one of our design space requirements is that the device can be removed from the guitar without damaging it at all. So we used GoPro mounts that have specific instrument adhesive padding that GoPro designs so that it's really easy to remove just the assembly from the guitar, and you can leave the little clips on there. The battery pack is adhered the same way. And if you ever wanted to restore the guitar to its normal place, it's a lot like those command strips where you just pull on it and it comes off of the guitar without leaving any residue.
One question while you're setting up. Sure. The mouthpiece, is that replaceable? Easily replaceable?
The whole thing or components of it?
Just the part that touches the person's mouth.
The tube? Yeah.
you can pull it out.
Yeah, it only interfaces, it just slides in straight through the hole and interfaces straight to the pressure transducer. So literally you can just pull the tube out and put a new one right back in.
It's a pretty tight fit, so it takes some. But yeah,
Some muscle, but
Right, okay.
yes, it is
It's not,
replaceable.
there's no adhesive or clamp or anything, it's just press fit onto this.
And that wasn't custom made, correct?
No, it's aquarium tubing. So you can just buy, I don't remember the exact diameter offhand, but you can just buy aquarium tubing off Amazon, cut it to length and insert it in. That's what that is. So he's switching over to calibration mode right now, and you'll be able to see that the two axes on the mouthpiece will allow him to rotate the pick arrays in and out away from the sound hole, so that the user does not have to, again, assuming they don't have control over one of their arms, they can use their mouth and their head to
Which way is better to make you guys see it?
orient it.
And then, yeah, because you don't have the switch, so the switch between calibration and playing, you have to switch between these two. But whatever, when this gets powered on, wherever it's sitting, it takes that at its 0. So it needs to be just for that sake. But if you had a button, you know, then it wouldn't be a big deal.
Need an extra hand.
Yeah, I need more than 2 hands. It's a great selling point.
You can see, it's rotating up and down.
You set your pick depth.
Because we're presenting and nothing works when you present.
Because that's an hour this morning. So up and down, it's supposed to get us the other axis. Same place. So it took the 0 as it, you know, sagging.
So ideally, when the custom pick holders are designed, this is all the user should have to do is just rotate them in. Chances are he'll have to manually adjust a few of the picks in there because they may not be at the appropriate depth even after rotating the picks in like that, because 2 of them might be at the right depth and then the other one might not be. But again, that should be resolvable just by redesigning the pick holders so that they're custom for each string.
Another thing with the calibration mode. So when you put it in calibration mode, initially it zeroes all the picks as well as the arrays. So meaning it, so you put in calibration mode and it'll turn all these to vertical, so you know how to orient your pick holder when you first put it on. And if we had something with memory, you only have to do this once. Not spend hours and hours of your life, as I have.
So when you power it down, it loses this calibration.
Yeah.
How much does the add-along add to the cost?
That's the exact same price. You just buy a different board.
So any extra cost would just be the micro SD card you'd have to buy to install. But I mean, you wouldn't need a large one because it's not storing a lot of memory, so you could buy a cheap micro SD card to insert in there.
It's a little hard on some of them. I have a hard time not using my hand, sorry. And then for just normal playing. sweet spot between the single string and the normal playing. And then the delay between, so if you just keep pressure on it, it will just keep going, and that's just a hard-coded number, so set value, because we lose the axis that changes that. So that's another reason we want that pedal.
So you can see as he's up there, it's playing all 6 strings, and then as he lowers his head down, it's only playing the bottom 4 strings. Right in the middle is 5 strings.
Sweet home Alabama.
Yeah.
Sweet home Alabama. He said.
Oh yeah.
I was gonna say peace of mind.
Easy, yeah, easy.
I tried playing that one. It's hard to play,
Yeah,
but I'm not very good at using this yet.
Yeah, so it's it's awkward for me to play this. I'm sure the actual end user would have a little easier time with it. But something we'd mentioned to Rude and something he thought was great is you can increase your ability with the device by your breathing patterns and your head motions. You'll get a feel for where everything lands. And so it is kind of like starting over, playing, but it's learnable.
Yeah. And we have it set that it's pretty sensitive when it reads your breath input, so it doesn't require very much force at all. And if for some reason that wasn't natural to someone, it would be easy. There's just a constant in the code that you can change that adjusts how sensitive it is to your breath input, so you can kind of customize it to your personal preference as well.
Do you identify that in the literature?
I believe so. Do you?
Huh?
Do you have that labeled in the code?
Yeah. So the code is everything is called something. It makes sense what it is. So like this is the breath value. There's the strum value, the speed value of the analog inputs that it reads. I need to go through and comment it though in case there's somebody who doesn't know how to code that wants to change it. But almost everything is global constants that can be changed. So it's very extensible and everything. The actual loop function is really small. It's almost all external functions that just get called with the parameters that it reads in.
Can you do an E progression with bar chords, do the changes just to see how that works? Or progression that you're comfortable with?
Yeah.
You gotta stick it in there a little farther.
No, it's the double shaft.
A bar chord doesn't change its abilities, right?
No. The only reason it would is if you have a high action guitar, because obviously you're moving all of the strings down at that point. But you can see right there, he's got a bar chord and it plays just fine.
Yeah, my suspicion is on the action that's set up way before this thing ever gets attached to something.
Right.
Because somebody who plays the guitar, that's the first thing to do.
Is lower the action. Yeah, it's common enough that we suspect most people would do that, but in the case that someone doesn't, we recommend that that's the first thing they do before they install it.
But just to demonstrate more kind of what we were talking about. Yeah, we lose it as I move up, the string's getting, that distance is shortened so it goes lower and lower, which can be accounted for by blowing harder.
Can you do harmonics? Curious?
Not currently, but where we have it so you can switch between like note mode and chord mode, it shouldn't be that hard for someone to add that
You
in.
probably do natural harmonics, you couldn't do pick harmonics.
Mm-hmm. Oh, I'm sorry. I was thinking like double stops. You meant harmonics.
Yeah,
I'm sorry. I
harmonics,
misunderstood.
Yeah. 12 fret harmonics.
Yeah.
So you do natural harmonics, but you couldn't do a pick harmonic. I can't do them anyway.
I
certainly couldn't.
It's a 50-50 shot anytime I try to. So.
It's not beautiful. Don't let this be a message of it, more of my playing ability using it.
My suspicion is they're gonna love it. I mean, the fact is that anybody who picks up this device is gonna have some uptime.
Yeah. Oh yeah. It's
So,
you're not going to pick it up and go right back to where you were. The one other thing I forgot to mention. So part of the reason we haven't uploaded all of it is we have enough spare parts to completely rebuild it. I'm going to buy an Adafruit logger myself, and I'm going to rebuild it from the ground up with pictures, maybe some videos and stuff. We have a schematic, but a lot of people can't read a schematic. A lot of people can't write code, so it would be a lot more simplified, in-depth, step-by-step. If you know nothing about any of this, you could build it. Kind of is what we're going after.
And that's very much the format of Instructables. If you haven't been on there before, is it's very, picture step by step, video step by step, and that's what we want to do for Rude, to make sure that this is as simple to work with as possible for anyone who decides to take it.
And the one other thing is apparently it's a thing of the battery packs that I read is pretty common in the Arduino world. These have like a minimum amperage requirement, or they won't pull. So when this is being used, it's fine, but after it sits idle for, I think it's something like 60 seconds, the battery pack shuts off. So this just kind of freezes where it is, but it's actually turned off. So then if you blow into it, nothing happens. So it's turned off. One way to prevent that is there's a pin on the board that's VBAT. So it's the voltage from the battery, but it's scaled down to 3.3 volts that the board runs at. If you just put like 100 ohm or some low ohm, or a LED is another common one, just bridge that and a ground. So there's just something pulling just a small 25 milliamps or something all the time. So when I do the second build for the Instructables, I'll throw that in there too.
can they swap out the battery pack and use something else?
Yeah, they can. So that we went with USB because it's universal. So when I'm playing with it, this one is for the controller, is plugged into my computer, and then the servos are just powered off the battery pack. But so the GoPro mounts you see here, like Stephen was mentioned, is the 3M adhesive pads. So they come with replacement ones, and we just stuck this to the guitar with the extra one of those. So if you need to charge this, there's a charge port here. We did it with the intent that this is pretty low profile, and so are these mounts. It still fits in the case nice. It's still highly mobile. And someone who does this isn't likely going to take it off. But if you want to, you can with zero effect to the guitar. But there is not a convenient on-off for the battery. It's just on there. But any USB power source would work. Well, it has been. These pull about, I think when I measured it was close to 200 milliamps at full stall torque. So, with 6 of them, these put out, this is 3 amps per port. So, there is that, I guess. It would still work, it would just get hung up, probably. It wouldn't have enough power to hit the stall torque that it's rated for. Which we still aren't. These are actually rated all the way up to 6.6 volts. And they're running at 5.
Any other questions?
I think you guys have done something pretty cool here. Should be proud of. Excited to see, future iterations and what comes of it. Because I imagine once you get it up on the Instructables, it will get some use, which is pretty cool for a university capstone. Anything for it actually to get used. There's a pretty small percentage of it where what they come up with really has the kind of impact that yours at least has the potential to do. So that's cool. Had a couple of comments related to your requirements. So did you pull the short straw for having to talk to the requirements?
Do you want us to go back to slide?
Sure. High pressure environment, I think you pulled off the presentation well. When you got nervous, you used feel more, which is like the wrong thing to do, but it's very natural to do. the way that this works in an industry environment is that as soon as you found out that, hey, this isn't going to work, you immediately go to the person who's the approver for whatever it is that's done. So it's look, okay, this is what the previous requirement was based on. Because it was based on this, this is what we would propose changing it to, because these functions or capabilities aren't possible without doing these additional things, type of deal. And you talked through a lot of that, but you want to do that at the time when you're in the industry setting that it first comes up. You don't ever want to show up to a design
Wait till the
review,
presentation.
because they'll eat you alive. So you don't want to show up with something that isn't. You want to have it renegotiated once okay. So, and I think that you did a good job about talking about what wasn't possible based upon which assumptions, like the assumption of, okay, we're not going to actually change the. You talked about later having some ways to get up to a higher decibel, but I guess I kind of missed that once you got to it later on.
Well, with higher, just being higher powered servos could let you go deeper without stopping.
Okay, and those are an option that you know of and would fit in there.
Yeah,
It would be a bit of a redesign, because this I guess, chassis size of servos is the micro servo, and the next step it would be a mini servo, but body size is almost twice as tall and about half again as wide. So we'd have to revisit if it would fit in a linear arrangement like this.
So when you went to the approving individual, you bring a skeleton design of what it would take to do it, and what the cost would be associated with it in terms of time, capital, all that jazz. The other one is that you may not have it this way in your document, but here it shows low cost. And
Yeah, I only worded it that way because I was trying to fit it on the slide here. We have a whole paragraph describing what open source actually is, and we give a range initially of we're trying to achieve 250 to 500 for the cost of the breath strummer, but that didn't fit very nicely in the little table on the slideshow.
I thought that was probably the case. Make sure that that's clear, at least when you're talking about it. If it makes it easier in your presentation to have it on a separate slide, again, this is all for future stuff. Put a separate slide on that has the different things that breaks into and how you achieved each of them.
Okay.
Just because, kind of remembered that you had something in there, but
Not the details of it.
that pain in the butt quality engineer who didn't read any of your stuff before he showed up, again, is going to take you to task for it. Any quality engineers in here? Okay. I can take you anyway. So, I already answered the Adafruit versus Adalogger. Just out of curiosity, does this have nylon or steel strings on?
This is steel. The one I'm building it on will be a classical acoustic with nylon strings, and the string spacing on those is also quite a bit more than this. It's a lot wider setup.
Okay.
But
That's kind of something we didn't talk to. So this is just a slit, and these are held in with just screws and bolts. So when I did it, I just assembled it, and these were all just kind of loosely in there, and I just eyeballed over the top and then tightened them down. So it can take a guitar it'll handle wider than the widest guitar we can find.
Cool. So what about having an adjustable angle that you have there instead of individually redesigning the pick holders?
So something we kind of thought of initially was so the pick holders have some sort of like a spring mechanism in them, so that they're they look the same, about like that, but it can kind of like a bar door, can swing either way. So as it engages on the string, it kind of makes a drag out of it. Part of the reason we didn't end up going with that is it would be you have to have a fairly stiff spring, and there's not, because it's only engaging one string and not multiple. to have it lay over and then brush over the string, then it's probably gonna come out and slap the next string that's next to it, when it straightens back out. So you have to have a little more travel if you drag it.
Were you asking about how to compensate for the different plans?
because it seemed like you had two
Oh,
different
sorry, I
planes there.
misunderstood.
Where what if you just changed the other
The
plane
incline.
so that it matched?
That's an option too. I guess we could have looked into that a little bit more than we did, but you could shorten or alter the leg so that it did sit at more of an incline. That would kind of fall into lessons learned. That's probably another measurement that should have been included early on, is how much of a angle are we dealing with, and is it standard enough across guitars that we can design the legs for that, or in the case of the pick holders, one advantage of that is you can customize those to each guitar, and the cost to print those little pick holders is very low. So redesigning those is a pretty low cost way of compensating that difference. Whereas redesigning the legs is going to be a little bit more. So if that angle's not standard across all guitars, you might run into some issues where it could be more costly to handle it that way.
That makes sense. And I'd encourage you to include that as a possibility, just because for a layperson, changing the design of the pick is maybe harder than adjusting a screw on the side. And having that screw on the side, adjustability might be nice for other reasons too.
Right.
Just the general height of strings.
And I may have failed to mention it, but the other option to just redesigning each individual pick holder is you could just insert some sort of spacer in there, just whether that's a piece of rubber, because we're already using rubber to hold the picks in the pick holder anyway, so you could pad it with some rubber at the top or some other material.
Makes sense.
And do that, because they're deep enough, like you wouldn't ever need to go deeper than the way we've designed it, so you could easily add on to decrease the depth that they
Which
go
is what
in.
we've done. We set them, so when I did the first initial setup, put all the picks at full depth, and then, so I brought it down until the first one or two strings engaged, and then pulled the other ones down a little bit, so that all three on the array engage. So on any one array, no three of the picks are at the same depth.
Cool. Another improvement that I think would really add value to it would be adding a method to spring center your mic.
We've talked about that, yeah. The two-dimensional joystick potentiometer is spring loaded, so it does return to a neutral, but just with the weight of our housing, it keeps it down.
So it's a spring strength type of an issue.
Yeah.
Which, when we initially got it, was like, it's actually pretty stiff to move just with your fingers. Like, oh, this will be fine. And then, pick it up and it's all droopy. It holds the weight of this side okay, but it's this, and especially with the Ethernet port on it. So.
But it is, it does return to neutral, just it's not strong enough.
Cool. Do you have any idea if there's string or springs on the market that are the right size that you could just swap those out for? How hard would it be?
I don't know.
I have no
I'm
idea.
not sure. We haven't really explored that. Because like I said, most of the time I've been playing with this, I've been holding it like this, going into it, using my fingers, because I don't have a microphone stand at home. So for all that, and then, when we start actually getting into it, so the first time I used this was today, put it in, and I was like, oh, that's kind of difficult.
After installation.
Yeah, this is way easier. Why don't we just do this?
We might have to edit that out. The last comment that I had that was more of a general one, towards the end, again, as you got uncomfortable, you started using the term believe a lot. And that's another one that you want to generally avoid as an engineer. Tell them what is, and if you're not confident about it being with making it an is statement, just leave it out. You're better off that way. So, and I think that you had sufficient evidence there where you could have changed it to is. I think that it was just that you got uncomfortable in the moment. So.
Defaulted.
Again, that's the cue for the sharks in the room. That's the blood in the water. And that's why I keep pointing it out, because I've been in those meetings where everything's fine with the design, but you end up having to go back and rework something that wasn't broken because somebody pounced on something like that and started a chain reaction where you can't control it anymore. So that's it for me. Right?
One other quick comment to add to that one. Most people, when they get in a meeting in business, feel like they have to do added value, right? So they're gonna make a comment on some minutia because the boss believes, oh yeah, that was an interesting comment, it may add value to the process. That's what Spencer's talking about. You'll get people just commenting on silly stuff because it gets points scored, right? And for no other reason, and it may have absolutely no real effect on the product. So you gotta, if you can, think through all the possibilities of questions that people might ask you, and be prepared with answers. And you'll never get 100%. Of course, it's always a good thing to try to do as much as you can. And then I just have one quick question: who set up the very volume rating?
That was
Whose requirement was that?
so. When we talked to Rude, he didn't have a specific volume initially, so we did some tests ourselves, just playing the guitar. Just, when I play a song softly, how loud is it? And used our decibel meter to measure that. And what we found is we were typically playing between a range of 65 to 80. So we said, okay, if we're playing that for our songs, that should be what is expected for most guitar players.
Rude didn't provide us with any numbers for any of the requirements. It's just needs to play soft, play loud, play fast, play slow.
So
yes, we gave ourselves some quantities for testing.
most of the time, these things are mic'd, right? They're either mic'd or they're amplified.
Mm-hmm.
And the difference between 65 and 70 won't matter.
Right.
Because that's all done in the amplification. So I was just curious if that was something that we would say, yeah, gosh, you gotta meet this.
No, just they give us an actual target instead of some ambiguous theoretical value.
So it's not backing off what Spencer was saying. You put it up on the board as a requirement, it's gonna meet it.
Yeah.
But that's just from a practical standpoint, I think it's gonna be.
Yeah, and that goes back to what was the source? The source was you.
Mm-hmm.
And you had good reasons for it, right? You had good reasons, but then you go back to, okay, what other arguments can we make that this is acceptable, if we really feel like it is? And then you put those in as the modified source. The original source was by you, the modified source is by you. There's no real difference there other than that, if you're logical and present it to a reasonable customer at least, they'll be like, yeah, it's fine. And you change it, and those added value guys have to find something else to needle me on.
And they will. I think you guys did a wonderful job on this. And I think it's something you can be proud of going forward. Couple of real quick things. The specs to print materials, is that all going to be part of what you send to Root?
Yes, those files already exist.
Okay. Is that in a language that he'll understand?
So the printing files are just STL files that you would take to someone who prints, and then they're ready to
The
go.
user doesn't need to do anything with them aside from provide them to
There's no interpretation between languages?
Not at all, no.
English and, okay, all right. And the other thing is it possible for one of you to remain in contact with him for a little while?
Yeah, I've been in primary contact with Rude. So
Okay,
he's welcome to email me to his heart's content.
yeah, so when he tries to do his first iteration of this, that he's got somebody you can call and say, well, how would we do this?
Work.
Yeah, that'd be great.
Yeah,
Because this really is, I think it's gonna have legs. I really do. And it'd be great if we can have somebody that's stuck in there with him long enough to make sure we've got.
I'll be around.
Great. Good job, guys.
Thank you.